to be here today and to meet everyone. So we already have our introductions, so kind of moving right into our presentation here. Just a visual. We will, as we go through this, we will continue to kind of tag through this presentation. And I think we're ready to jump right in.
All right. So we're kicking this off. It's based upon our book, which recently was published, I want to say October, on industrial DevOps. And one of the things that we're going to talk about is change, right? Change is the common thread that runs through all businesses, regardless of industry, size, or age. We're actually seeing it at exponential rates right now. For space, for example, recently I was told that we'll expect to see more change in space in the next 5 years than we have in the last 50.
Wow. That's pretty amazing, right? And we see change all around us. So as we are kind of doing this introduction to industrial DevOps, it's always great to kind of level set and kind of provide some context, because I'm sure many of us are probably familiar with Agile, and we want to kind of highlight, Agile is that empirical process, right? Waterfall was very predictive. I could map it out. I could plan it out for years, and we can debate how well that worked, 40 years ago, or but today, because of that change that's happening, we need that empirical life cycle. We need to take complex problems, break them down into the small, and then iterate on them and get feedback as we are working our way through that complex system and learning along the way, so that we're constantly feeding that learning into our process.
So what's industrial DevOps? Really, it's DevOps beyond software. So one of the things that both Suzette and I had a lot of experience with, so I spent a long time at Lockheed Martin, she's at Northrop Grumman, is building large-scale safety-critical cyber-physical systems. And both of us had an opportunity to see places where we could go really fast in software, but it still didn't matter to our customers because they didn't get the software because the cyber physical system wasn't ready. And really what we wanted to do is discuss all of the things that we could do to optimize the flow of value for cyber physical systems. Now we borrowed from multiple bodies of knowledge, right? We didn't just come up with this. We borrowed from lean manufacturing and product development, lean startups, systems thinking, scaled agile, DevOps. So a whole range of disciplines that already existed. And the key that we try to do is link them together, right? Because you probably see this in organization. You've got specialists in each of these fields, but they're not actually being able to optimize the delivery of the system because they're still working pretty in a stovepipe way.
And just as Robin was saying, we saw Agile in software, and as we were working though with our programs that had significant hardware and systems engineering and other functions, it was great that we could do Agile in software, we could iterate, but we still couldn't get out the door. And all we were doing is shifting the bottleneck. So if some of you have ever read The Goal, I happened to be reading The Goal at the same time where I first experienced this, working on a radar program. And, software, had challenges. We went in and the teams did such a great job. But then I noticed we still couldn't deliver. Then I was like, what was the point? Software was great, so there was definitely benefit. But then that's the aha moment, right? Is I got to apply systems thinking. I got to look at that whole value stream, not just software. And that is, for me, one of the first steps on this journey. So when we talk about cyber physical systems, we're talking about things like the F-35 or the B-2 or satellites, submarines, and radar systems, those things that have significant software and hardware components.
So what are some common problems we see? Number one, lack of alignment across many stakeholders. I bet you see this all the time, right? Because we have different perspectives and different mental models. And language isn't good enough, right? We often talk past each other. Lack of transparency, right? So we go off into our own individual stovepipes. I'll tell you when I'm done later. We'll get back together. What's the likelihood that we're going to all have the same information? Not much. Uh, Nothing is done until everything is done. This is the worst possible approach to deliver a system. If I don't know and I can't validate anything until the whole thing is complete, especially when I'm building, let's say, a satellite, that's way too long before I can get any feedback. Multiple delays due to bureaucracy. We still have quite a bit of that. Now, a lot of the bureaucracy, is put in place for certain reasons, to solve a certain problem. However, we don't ever spend some time to clean that out based upon our current context and our current date. So we bring it all with us. And then obviously long lead times for hardware procurement. All right. So we absolutely understand that and realize constraints of physicality cause us some delays to be able to get some feedback.
So when we take into account our challenges, we also want to talk about the benefits, right? Which is kind of the flip side of once we overcome those challenges, right? We want to be able to deliver value in the shortest sustainable lead time. So, what does that mean? So we might be familiar with Agile, we're familiar with Agile frameworks, but keeping sight of what's really important is the value delivery. And we want to be able to do that in the shortest sustainable lead time. So if you may not be familiar as much with lead time, maybe some of you. So lead time is the time from when we get a request or need comes in from the customer to delivery. And how can we do that? And especially in cyber physical systems, how do we do that? How do we embrace or take advantage of some of the digital capabilities that we now have available to us? And we'll highlight that as we go through some of these principles that we're going to be talking through. We want improved collaboration and knowledge sharing across all functional areas. So we had it within software, but now how is software engaged in hardware and engaged with systems engineering? And how are we pulling them together as a team of agile teams to deliver that value? Of course, we want to build a competitive advantage and we want to take advantage, right? Whoever learns the fastest wins. So we want to take advantage of the rapid learning, the experimenting to get smarter about the system we're building. Improved quality, of course, is always a focus, especially when it comes to cyber physical systems, right? Because they're significant, they're large, they've got some safety and security concerns that we need to ensure we're addressing. All about making the customer happy, delivering what they need when they need it, along with making sure we have our employees engaged in the process and finding ways that work best for them.
So I'm not going to spend too much time on this page because we're actually going to deep dive into each one of these. All right. But these are the 9 principles of industrial DevOps. And as you look at each one, you're probably going to say, yeah, I know. Here's the thing. We pulled this information from a lot of experience and a lot of bodies of knowledge as well. The goal was never to basically say, hey, we know lean better or automated test better. It's, hey, let's use all of the tools in our toolbox to deliver systems better. And that's our real message here.
Right, so our first principle is around organizing for the flow of value. And how are we actually organizing our team and our team of teams? And that's important because we want our teams organized to be able to deliver integrated system capabilities. So it's not just how is my Agile team doing, but how are my Agile team of teams doing? In this example, how are they working together in terms of building this attitude control system for an end-to-end value stream, which is the satellite? So, and building that collaboration, and you can see here we're pulling from
team topologies.
Thank you. It's like
not enough coffee.
Just flew out. Yeah, just flew out of my mind that fast. So maybe you've read team topology. So we took advantage, like just like Robin said, like what's already out there that's growing out in the community that they're seeing positive results. So from that learning, we actually pull it here into our team of teams, and we highlight that some teams might be feature based, some teams might be complicated subsystems, some teams might be platform teams, and then how do we bring them together again to deliver that value? And all the while making sure that we're getting feedback. It's not just about development, but how are we actually interfacing on the manufacturing side so that we're building for manufacturability and that we're finding design issues not out on the manufacturing floor, right? We need to shift that left and make sure that we're collaborating and finding it as early in development as possible, because that will reduce cost and that will help ensure or at least decrease the risk of schedule delays.
The next one we're going to talk about is applying multiple horizons of planning. And some of you may look at this and go, oh my gosh, we've been doing this integrated master schedule for years. What are you talking about? No, there's a very specific difference here. So a typical integrated master schedule comes back to what Suzette was talking about earlier, which is predictive delivery, meaning I have a 5-year schedule and everybody knows what Robin is doing in October of the last week in 2026. Unlikely, right? But we've all seen integrated master schedules. Now, we want a 5-year plan, right? We still need to look at those long term, but we need to look at it from the lens of empirical data, right? So we're breaking that down. We can have, a full 5-year plan, then we could break that down into an annual plan, break that down into quarterly plans, break that down into sprint plans, and then further even break that down into a daily plan. Now, here's the key. If I have a sprint or two, right, within, let's say, a quarter that I'm delayed on, where I have maybe completed, let's say, 80% of the work, the secret is it's likely that when I get to the quarter, I'm going to be 80% complete. Now, what I want to do is use that empirical data to further inform that next plan up, right? Because there actually isn't any magic. And if we don't actually use the data to adjust the plan, one of two things happens. One, we get with the customer and we wait all the way until just before we're delivering and we're like, you know what, we were just kidding. We're not going to make it. Or we start reducing quality so we can speed up and break things, in which case we probably still don't make it. So what we're really saying here is, while I have a long plan, right? Elon Musk, I want to hit human spaceflight in 2026. I am going to use empirical data that I got on my daily plan or my sprint plan or my quarterly plan and use that to adjust that future plan so that I actually really do have a predictable, understandable schedule that I can share with. And this is critical, especially with cyber physical systems, because we usually have multiple suppliers. We'll often have long lead item parts, things like that. And so we need to be able to bring that all together in a predictive manner. So that's how it's different than an integrated master schedule, like a roadmap that I'm adjusting and adapting. Here's that practical implementation. We've got, basically Artemis, right? Artemis has a plan and it goes out for many years. Actually, this shows till 2026, but it's much further than that. It goes out to 2030. And basically, they're running a series of experiments, quite similarly to Apollo. And each one of those experiments, each one of those launches is giving them data, in which case they're going to use that to further inform the future plan.
Yeah, it kind of reminds me a little bit about what SpaceX might be doing.
Absolutely.
Very similar. Right, so principle 3, implement data-driven decisions. So as we are measuring progress, right, it's not just, hey, what has my team done, or what stories they have done, which is all really important. But what we want to do is ensure that not only are the teams demonstrating their stories, but how are we also demonstrating integrated capabilities? And as we are demonstrating those integrated capabilities, it's again some sort of acceptance criteria. Something that we're looking for is that we're actually demonstrating and we know what that acceptance criteria is, and we can actually demonstrate how it's working. And that might be in a virtual environment at first, it might be in a simulated environment. And then as we move to a physical environment, it might be using some prototypes or 3D printing materials. Again, so we can constantly demonstrate what's actually working. And that is what's measuring progress and work completed. And you're probably very familiar with that based on the background that we saw from those that did the poll, right? We understand demonstration of capabilities is the true measure of progress. We get that. At the same time, we also now have these new digital capabilities that we want to take advantage of through our digital twins, through our dashboards that we now have. And we can actually see what is the impact of from the model, what is the impact of these new capabilities, and how is it going to impact either things that are already out in the field, or maybe how we are developing the system. And we can actually test through different scenarios and test against some of the requirements, because with physical environments, of course, our products, we actually have some real requirements. Like, is it going to be able to handle the amount of heat or the amount of cold, depending where it might be going in space? So we can use both our kind of the agile process that many of us are familiar with against objective evidence of work completed in concert with our digital tools now to test and shape the model and get that feedback. Just like they do, like with Tesla, they're able to test out new capabilities. They are actually able to get feedback from those cars or the vehicles that are already out in the field as they're testing new capabilities. And we're using all of this information to drive data-driven decisions of where do we need to go next? Is it working as intended? Do we need to pivot? Do we need to do something differently?
So the next one is architecting for change and speed. And again, not a new concept. However, we really want to make sure that we are looking at ways to modularize, right? To modularize that capability. Here you can see an example. This are architectural considerations. Usability, security, manufacturability, observability, right? All kinds of things. And each one of these has a set of trade-offs, not completely different, but the trade-off we want to make when we're building large-scale safety critical systems is to try to modularize as much as possible. Now, I know that in real-time operating system, we can't have any kind of delays or anything like that. So we might have to, in some cases, make the trade-off where we don't have as much modularity as we want. But as much as we can do this, because this allows me to make a change in the system and not affect everybody. Here's an example of a flight system. Again, looking at it from a modular perspective, right? So attitude control, guidance, navigation and control, logical flight, command structures. These allow us to really focus in specific areas. The other thing that you're going to find is if we architect things right, we can minimize dependencies, right? The first rule of scaling is not to scale, right? So if I can make it so teams aren't completely dependent on each other, if they can interface, through some architectural interfaces versus having to work together every day, I'm going to do that, right? It's going to give them the most autonomy. Now, one of the things we really have to focus on is right now we have a lot of legacy systems, and those legacy systems in many cases are very monolithic. So we can't just move our organization of people, and we can't just move our architecture overnight. We have to incrementally update it, leveraging things like a strangler pattern so that we can ring fence around an area and then keep pushing that out until we can refactor those monoliths into much smaller modular capabilities that allow us to make updates and deliver faster.
Yeah, so one of the examples and companies we've had the opportunity to talk with is Joby Aviation, which we're real excited about. And they are an aerospace company. They have an electronic vertical takeoff and landing aircraft. Um, and in some of the scenarios, I think they talked about their website where it needs to be able to like go from like Baltimore to Dallas, right? And making use of, being able to use that air taxi service and bypass the horrendous traffic that we have in those areas. So that's a little bit about who they are. However, once we were talking with them, we were really interested in how they were building their product and how they were using these concepts about, agile and lean and modular architectures. How are they using test-driven development as part of their product delivery? So, and if you've noticed, we're trying to feed in a few of these examples for you because people are always interested in what are some case studies where this is actually working. So these were some of the practices that they have employed. And it's all about, of course, in their situation too, of making sure quality is built in, because that was one of the areas that we talk about with cyber physical systems, ensuring quality, safety, and security is built into whatever that product or vehicle is that we're building.
All right. Iterate, manage queues, and create flow. There's a lot of conversation now about creating flow. And again, not a new concept, right? Many of us probably went through Lean Six Sigma. The theory of constraints is still a thing. So how do I take advantage of what I know and make sure that I can optimize flow? Well, the first thing I need to do is I got to visualize it, right? So these Kanban boards, things like that, incredibly helpful. The next thing I have to do is I need to understand what the queue looks like. If I can't see the work, then it's very difficult to see what that queue is. Also, with these stovepipe teams, it's very difficult to see you've got a queue over here. What's the next handoff and what's their queue, right? So being able to look at those together will allow us to optimize that delivery. We really want to make sure that we iterate on things. So not to deliver big bang anything. So Suzette talked about Joby Aviation. Every time they make a set of changes, they can actually push those all the way out from, the software onto the hardware, even onto the vehicle. They actually have a vehicle, which be pretty interesting to try to take a ride in, that they can prove and see their updates in. So one of the things that you'll see, for example, is I might want to work in my stovepipe for a long time because I think I'm going faster. But inherently, the system isn't going faster. So really focusing in this area on that value stream, being able to visualize and create flow is critical, especially as we move towards, being able to get capabilities to the warfighter faster.
So the next principle is focused on establishing cadence and synchronization. Right? In cadence and synchronization, you're given the experience levels of what we saw, you're probably very familiar. Right? Cadence is, something that's happening on a regular cycle. But my teams could all be working on cadence. Doesn't necessarily mean they're synchronized. So one of the things as we're talking about working at the systems level is ensuring that we are synchronized or have defined synchronization points across the different teams. So initially, like sometimes when they're just getting started, right? Just from observation and what I've seen, is that Agile often starts in software, right? And then slowly hardware comes in. And then trying to get them, on a regular cadence for planning or to identify where those dependencies are. And then we get to the point of, well, how frequently can you actually synchronize the work so that we can actually get an integrated demonstration? And, and that doesn't happen overnight. Initially, it might be like per quarter or maybe even 6 months. Not ideal, but maybe it's better than where they are today. And then we slowly, using our digital capabilities, we're able to get them into a shorter synchronization points where maybe they demonstrate not just every quarter, maybe it's every other sprint, and then eventually maybe every sprint. It kind of depends on where they are in that journey, but always focused on what is our cadence, how frequently are we going to demonstrate integrated capability. And what I've seen in some cases is bringing those hardware teams, people that are building hardware. It's not software here, hardware team, but let's get together for coordinated planning on cadence and then identifying our synchronization points so that we can go back. If you go back to what we're talking about, making data-driven decisions, the reason we want to synchronize is so that we can demonstrate those capabilities and make better informed decisions. And here you're seeing at the bottom of the screen, right? What are those MVPs, right? Your minimal viable product. You might be iterating in a virtual environment initially. When can we actually start integrating with real hardware? And just like with SpaceX, right? We're going to do some tests, we're going to learn from it, and we're going to feed that back into the next learning cycle, such as Robin talked about with multiple horizons of planning. So while we're talking about these principles kind of one at a time, they actually start working together.
So we know this one too, right? Integrate early and often. Problem is we tend not to do that. Now, when we start up a new program, you will find, especially for these large scale systems, this kind of staffing curve, right? Where we get started and then we get to a large point and then we come down. Now, for an agile and industrial DevOps type of approach, that curve is going to be much flatter, which means that I'm probably front loading some of the cost, right? And the reason I bring that up is because frequently, one of the reasons that people aren't doing this is they haven't purchased their hardware in the loop environments. They don't have their software in the loop environments. They're waiting till later. What we want is to begin with the end in mind. So have the environment early, invest in it early, and be able to push smaller changes through, not when we're done. All right. So we want to be able to, validate that the satellite can deploy their thermal panels, long before it goes into the air. And the sooner that I can start integrating and seeing that in a combined environment, the lower the risk I have is. If I'm waiting till the end and I'm like, oh, I'm going to integrate it at the end, that's usually the time we find out that it doesn't work, right? These systems typically have emergent properties. There's a lot of things going on. We want to be able to test and integrate small pieces all the way through.
And we want to also shift left. This is kind of like you might have heard of begin with the end in mind, or some of the ideas around test-driven development. But before we start developing, right, think about how are we going to test? Pull in the security requirements. What are the security requirements we need to think about? Design for manufacturability. Engage manufacturing at the right time so that we're getting feedback from them as well about how they're going to be able to kind of manufacture their parts, test out the work instructions that they get, digitizing those work instructions now, which is pretty exciting to see as a result of digital capabilities. And that helps us to think about, that test first mindset. What environments are we going to test in? That's one of the conversations I have frequently with my teams when they're doing the integration. It's like, let's talk through which environments are you going to use? What tools do you need? And oh, by the way, are there any resources that you are missing that we need to go either invest in or have more of? So for one of the teams I worked with, right, we were always kind of testing in the labs, but we were finding there were these challenges and we weren't able to fully test and demonstrate like we wanted. And come to find out, it's because other people were also testing in those labs and there was kind of a bottleneck in testing. So we're like, oh, we need more lab environments. We need more test environments. So let's make sure we're applying the investment in the right way so that the teams can have the tools and resources they need.
this is a great example of a company who's really understands this, right? Being able to shift left, integrates early and often, heavy duty automation. Planet Labs is part of what you would hear when people talk about new space, right? All of these new entrants into the market. A lot of these new entrants entered the market from the digital perspective, right? They were doing digital work first, and then they got to the physical. So they didn't have some of the technical debt that maybe some of the companies who've been in space for a really long time, right? We always started in hardware. The cool thing about Planet Labs is they've been able to have 14 iterations of their design of satellites in approximately, 3 or 4 years. They deploy a new satellite every 3 to 4 months. Now, how do they do that? One, they commoditize, right? They're not building a one-off satellite. They commoditize. Planet Labs really looks at Earth observability, right? The imagery, etc. So they've got smaller commoditized satellites that they're totally fine with, that don't last as long as our typical ones, but they've got a constellation of over 200-300 of these satellites. So when one goes down, right, they've got another one. So they actually optimize in two ways. They are basically able to agilely keep their constellation going, as well as they're able to, at the small level, be able to build and deploy new satellites at record speeds that you're not seeing in typical traditional space companies.
Yeah, and I think that's one of the kind of interesting things, right, about the digital natives, because they don't have to transform like some of the existing companies. A lot of the existing companies, that have been around for decades have that added complexity of transformation, where a digital native
starts there.
Yeah, they start there, and that's also, I think, one of the benefits to them is they can just keep running, and it'll be interesting to see how that continues to evolve over the next 5 to 10 years, because I think it's a great way to start, and transformation is hard. So our last principle here that we want to talk about is applying a growth mindset, and that's understanding of continuous learning. That we don't, a fixed mindset is, well, this is just kind of the way things are. It's always been this way. And a growth mindset is like, hey, maybe we can look at things differently. Maybe we can continuously learn. Maybe we can take that learning and then even learn from our failures to make us even better tomorrow than we are today. And this is where we start talking about fail fast, fail early, recover quickly because we're learning from it, and what do we take away from that learning? Part of that, though, requires, the right culture, right? You need your leadership that is open to those ideas. I also, you might have to have conversations. Well, what does it actually mean to fail fast and fail early? It doesn't mean failing at necessarily at launch time, but we're going to have these MVPs where we're testing and we're learning from those experiences. And an MVP, right there, it's not about failure, it's about the learning. Now there could be a significant launch, the real launch of the real product going into space, that we want to make sure that we've learned from those failures so that we have the best and highest quality product at the times when we need it. And in addition, this is where psychological safety comes into play, because we need to have an environment where, as people are learning, that they're not afraid to have these early failures. Again, as we're learning and building and working through the complexity, to be able to talk about what went well and what didn't go well, and what do we need to learn and feed into that next iteration or that next cycle of learning and planning. And it goes back to the feedback loops into the multiple horizons of planning as we continuously evolve and improve. And that's why it's really difficult. If you have laid out your plan, like we've seen traditionally with some of these large programs for years out, and they're really detailed, it's really hard. It's difficult, if not in some cases impossible, to get that feedback and update those plans because those plans have been so detailed out. So one of the messages, I think, from the multiple horizons of planning, we still plan and we still have a plan of where we're headed years out because we have to work with those suppliers and the long lead items. But the iterative piece of this is also where the growth mindset comes in as we learn from those failures and feedback into the next cycle.
One thing I'd like to add is be careful. You might think you already have one. I definitely did, right? But just a couple of years ago, I experienced a problem. You know, it was a problem for me. I had been pushing cross-functional teams, stream-aligned teams for my entire career. I knew everything I knew, right? I knew the answer. And then this book comes out, Team Topologies, and they talk about, hey, we can have a complicated subsystem, or we can have an enabling, or we can have a platform team. And I'm like, wait a second. No, I already had the answer. So even I, as an Agilist, had to reset myself and go, hey, the world's evolving. We're learning new things every day. I need to take even the things that I'm absolutely sure of and look at them from a perspective of what don't I know? What are things I could do a little bit differently? And accept that.
Yeah, and especially like how the world's changing so much right now. Like, let's just say for the sake of discussion, you actually had all the answers today. There's so much change that's coming tomorrow. That environment, that ecosystem is going to look so different. So we have to keep learning and keep applying and never think that we know it all because even if we know it all today, it's going to look so different tomorrow. And one of the yeah.
So one of the things I'm a big fan of is using all the tools in your toolbox. Again, we're not saying that we have given you deep information in any one of these. We're basically saying these all work together. They're not separate disciplines. They're not separate things. So if I want to get capabilities to my user fast, I need to bring all of the tools in my digital engineering value stream together. And I need to look at that flow across, not in any one specific area. These all help me get to where I need to go.
Yeah, I think an important part of all this message, right, is if going back to the beginning when we talked about all the different bodies of knowledge that come into play and being coupled with these emerging digital capabilities. So I think agility and applying agility across your value stream just looks so different today than it did 15 years ago. And I think it's because of these tools that actually
speeding it up
and enabling this to be agile in cyber physical systems. Like 15 years ago, we didn't have to the extent all the tools that we have now, which is why I kind of hypothesize we were not talking as much about agile and hardware 15 years ago. But all these tools that we have now in our toolbox, now we can actually apply agility into hardware because we have this digital ecosystem going on. And then how to get started, right? So we talked about these 9 principles of how do we actually build a culture where we lead by example, where we can embrace change and we can learn from that change. And it's kind of broken down into kind of 2 areas, which is really around your alignment, and then one is around execution and delivery. So always start with understanding your foundations and who's actually driving change or adoption and you're part of the organization, wherever that is. What does leadership need to do, right? Because it's not just agile and agility at the team level, but it has, when it's crossing the whole value stream, it also has impacts to the organization. So what is the leadership team doing? Because they are the ones that can help change the organization. So we talked about one of the challenges, right, is around bureaucracy. Well, the leadership are the folks that can help remove the bureaucracy and help us have processes that are internal that are also enabling us to respond to change faster. How are you organizing for change? How are you organizing your team around that value stream so that they can actually integrate and demonstrate together in an integrated environment? You might have to rethink your planning or restructure how you're planning Do you have cadence and synchronization? So I'm not going to go through all of these because we've already talked about the principles, but they are, you have to be intentional of where are you now? And then if you're taking those steps to improvement, which areas do you want to focus on next? And then if you're not familiar with the improvement kata, right? When that goes back to applying a growth mindset, it's understanding the current state and then understanding what is that future state, and then what are your steps for continuous improvement to reach that next future state. And that will continuously evolve as you continue to mature in your practices.
All right, so we're at the end. Reach out, leverage industrial DevOps, and really look at how we can increase transparency, reduce lead times, increase value for money, and innovate faster.
With a little bit of a delay. There we go.
That's okay. And here is a QR code so you can get your first chapter if you want to see, take a look, see if we're any good at writing or not. Although I got to tell you, the publisher is awesome. And so here you can take advantage of that. And I think there's one more.
Yep. And we also have some papers out there that are already published. These are free. You just need to go to IT Revolution. So if you're familiar with Gene Kim and the Phoenix Project, it's the same publisher. So it's out there, and if you want to start here to see if there's interest in your organization, or if you want the details, the book has more details and elaborates. In these papers, we use an autonomous vehicle as our example. And the book, we use satellite constellation, which is where many of our graphics came from today. And I think that's it. We have some time for questions.